video on mean absolute deviation. By the end of this video, you should be able to describe the mean absolute deviation in words, calculate the mean absolute deviation, and compare mean absolute deviations in data sets. So let's take a look. What is mean absolute deviation? The mean absolute deviation is the measure that gives the average distance of each data value to the mean. It's just saying, on average, how far is each data piece to the mean. So let's do an example so you can kind of get a feel for this. So the first step is going to be find the mean. So we're going to take our data set here and we're going to find the mean. So that means we're going to add up all the numbers. So 2 and 4 is 6, plus 6 more is 12, 19, 27 plus 15 is 42. And there are 1, 2, 3, 4, 5, 6 numbers. And 42 divided by 6 is 7. So the mean is 7. The next part is find the distances of each data value to the mean. Now, a distance is a positive number. We cannot have negative distances. So if you end up with a negative number, just drop the negative off because we only want to know how far away it is. So we're going to take each data value. So 2 minus the mean. Now that would be negative 5, but because we're talking distances, we only want positive numbers. And then we'll go the next data value, 4 minus 7 would be negative 3, but we're just going to leave it 3. 6 minus 7 would be negative 1, but all distances are positive. 7 minus 7 will equal 0. 8 minus 7 equals 1. And then 15 minus 7 equals 8. So now what we want to do is we find the mean of the distances. So all these distances that we found right here, we're going to find their mean by adding them up. So 5 plus 3 is 8, plus 1 more is 9, plus 1 more is 10, plus 8 is 18. And there are still 6 values, and 18 divided by 6 is 3. So what does this mean? So 3 means each value's average distance to the mean is 3 units, whatever your unit is. So on average, each number is 3 away from the mean. Right? So here's what we can do when we have MAD. It can help us compare. So MAD, mean absolute deviation, is a measure of variability. So it helps us understand numbers, how spread out they are. Are they more alike or are they more different? So what we're going to do is we're going to find the MAD for 3 different data sets. So the first thing we want to do is find the mean for each one of these. So add them up and then divide. So add them up, divide. So stop the video, find the mean for all 3 sets, and then come back. Alright, so when we look, you will notice that the mean for each one of these is the same number. They all have a mean of 9. But when you look at their numbers, you'll see a bigger range, a slightly less range, and then there's like no range because all the numbers are exactly the same. Alright, so we're going to look at the MAD then, which will tell us how variable are the numbers, how spread apart are they. So remember, we found the mean, which was our first step up here. The second step is find the distance for each data value, and remember distances are positive. So we have 2 minus 9 would be negative 7, but it's a distance, so 7. 4 minus 9 equals 5. 6 minus 9 equals 3. 15 minus 9 equals 6. And 18 minus 9 equals 9. So now we have all these distances right here. We're going to add those up and divide by 5 again to find the average distance. So 12, 15, 21, 30. So these add up to 30. I'm going to divide that by 5, and I get a mean absolute deviation of 6, meaning each of these numbers, on average, is 6 away from the mean of 9. Okay? Now, same mean, different set of data. So let's do the same thing. The data value minus 9, and we're talking distances. 7 minus 9 is going to be 2. 9 minus 9 is 0. 10 minus 9 is 1. And 13 minus 9 is 4. So these are our distances from the mean. The average distances, add them up. 3 and 2 is 5, 6 and 4 more is 10. And there's 5 data points. So the average distance from the mean in the second group is 2. And remember what we were saying, there's a pretty big range here, smallest to biggest. And this range is smaller, so the numbers are closer together, so their MAD is a smaller number than the other one. Now we're going to look at our last one. Each one of these, 9 minus 9 is 0, 9 minus 9 is 0. Every one of them turns out to be 0. So when we add them up, we get 0 divided by 5, so the MAD is 0. These are all the same number. They have no distance between them at all. So the average distance is 0 because they're all the same distance from the mean, which is 0 away. So what you want to take away from that is the closer your MAD is to 0, meaning the smaller your MAD is, the less variation in the data there is, meaning the more alike the numbers are. So if you have an outlier, that means that number is unlike all the other numbers that were there, so it's going to make your MAD increase. It's going to make your MAD bigger because it's away from the numbers that are already there. All right, let's do a couple practice problems and see how you do. All right, so let's try this first problem. We need the average, the mean, so add these all up, and when I add them all up, I got 430. And there's 1, 2, 3, 4, 5 of them. So that makes my mean 86. We're going to take each data value and subtract 86 from it to find the distance away. 90 minus 86 is 4. 81 minus 86 is 5. 85 minus 86 is 1. 92 minus 86 is 6, and 82 minus 86 is 4. So we got the average, we got the distance to the mean, and now we're going to find the averages of them. Add them up. 4 plus 5 is 9, 10, 16, 20. So they add up to 20, and there's still 5 numbers, so the mean absolute deviation is 4. All right, we're going to do just one more of these. We'll do this number 2 one. When we add up all of our numbers, I got 72. And there is 1, 2, 3, 4, 5, 6 numbers. So there's a mean of 12. So let's take each value. 1 minus 12 is 11. 5 minus 12 is 7. 9 minus 12 is 3, 16 minus 12 is 4, and 29 minus 12 is 17. Okay. And I did forget one of my numbers. I forgot 12. I skipped right over it. So 12 minus 12 is 0. So when I add all of these up, I get 42 for the distances added up, and there's 1, 2, 3, 4, 5, 6 values. So I have a mean absolute deviation of 7, meaning the average distance from the mean is 7. So alone they might not make too much, but if I were to compare these two, I would know in number 1 the numbers are more alike because the MAD is closer to 0 compared to the MAD in number 2. In the MAD in number 2, the numbers are more unalike. So hopefully that was helpful. I'll see you in class.